Okay, I have the satellite positioning box up. It's just waiting for me to push the enable button and release it. You ready to go?
We are ready.
Commander Kevin Ford getting set up for the Spheres experiment that's about to take place on the space station. And to tell us a little bit more about what's going to be going on with Spheres today, we have Terry Fong on the phone. He's at the NASA's Ames Research Center in California, and he is the project manager for the Human Exploration Telerobotics. Terry, are you there?
Yes, I am. Good morning.
So tell us what Spheres has to do with Human Exploration Telerobotics.
Sure. The Human Exploration Telerobotics project is one that NASA is using to look at how remotely operated robots can really improve the way that we conduct human spaceflight missions. And this project has a number of robots. Some people may be familiar with the Robonaut 2 system, which we've been testing for quite a while now on Space Station. What we're doing today is basically upgrading these spheres. These are mobile satellites, these volleyball-sized free flyers, which have been on station since 2006. To date, they've been used primarily as satellite test platforms, and today we are turning them into free-flying robots.
So these balls that we see floating here on the screen in front of Kevin Ford, that's a robot.
Mm-hmm. Well, it's turning into a robot now. I mean, when the spheres were originally built, this was more than 10 years ago. They were actually created by MIT. They were meant to be these free-flying platforms for testing satellite control. So they could do things like fly around in formations. They could to approach and dock with one another. But they're really, meant to be these moving test platforms for just checking out basic flying and control maneuvers. What we've been working on for the past year and a half is to turn them into what most people would consider to be robots. That is, we needed to add sensors like cameras. We needed to add more modern computing. These spheres, when they were built more than 10 years ago, as you can imagine, it's a long time ago in computing terms, had a pretty slow digital signal processor. We wanted a more high-performance computing platform. We wanted to also have high-bandwidth wireless networking and all the sorts of things that you would find in just any robot you would find today, whether it's in the home, office, or in the workplace.
Wow, that's really interesting. So, what's the purpose of having these on Space Station, as far as you're concerned?
Well, I think that there are a lot of things that go on Space Station, and it's great. We can actually see Kevin Ford setting up the spheres with basically upgrade, and that's an interesting story in itself. But looking at free flyers, the interesting thing about them is they can do things such as conduct interior environmental surveys. Part of the routine work that the crew has to do on Space Station is make sure that the environment is safe to live and work in. So they routinely go around and they measure different things such as light, sound levels, radiation levels, verify that there isn't buildup of things like carbon dioxide in various places. And of course, in Space Station, you can't just hang sensors everywhere because you need to have space for people to move around in. And so what we're trying to do is use these free-flying robots to do these sort of routine, mundane, but very important tasks such as monitoring the environment inside Space Station.
Okay, and this is just an experiment to see if it can do that at this point, or is it actually we're going to use the data it gathers today?
Today we're doing an experiment to really understand how this is practical. One of the interesting things here is, though, even though Kevin is in the middle of setting this up, once everything is configured, we are actually going to be operating these from Mission Control in Houston. One of my engineers, Mark Masiri, is actually sitting at Mission Control, and once Kevin gets all the upgrades installed, then Mark will take control and actually fly these robots from the ground.
Wow. Okay. So what will we see happen today?
So today, as I mentioned earlier, one of the things we've done is we've taken these free-flying satellites, the spheres, and upgraded them. And the experiment today is actually interesting. We're calling it Smart Spheres. And the reason we're calling it Smart Spheres is what we've added is an off-the-shelf commercial smartphone. So you take a smartphone and a sphere together, and you have smart spheres. The smartphone, of course, it's something that we all carry in our pockets these days. They're wonderful little computing devices. They have a 1 gigahertz processor. It's got a nice touchscreen display, cameras, Wi-Fi, everything you need to make a robot except, something to move yourself around. So that's what Spheres gives us today. And so Kevin has been spending basically the past hour or so working to upgrade the Spheres. Actually, it looks like he's managed to get everything installed. At this point, I think we're going through some checkout procedures in which Mark at Mission Control is just verifying that he can use the smartphone to control the Sphere. So from Mission Control, Mark talks to, with some software to the phone. The phone is then cabled into the Sphere and uses that to actually fly the Sphere around inside of space station.
So not only is it controlled from the ground, but it's controlled by a phone on the ground.
By a phone on the Sphere. So we've actually taken a phone and attached it to the Sphere itself.
Okay, I see. Okay, and then they're going to, I guess, command it to start taking photos, or?
Yeah. So today we're as I said, we're really interested in using these free flyers to do sort of routine environmental surveys or interior surveys. So one of the things we're doing today is we're going to fly back and forth in sort of a parallel line pattern, a systematic kind of survey pattern. And we're going to be using the camera on the smartphone, one of the cameras, to acquire continuous imagery as we're flying. This represents using any sort of sensor or instrument to take routine measurements inside of an environment like space station.
Okay, and I guess that's kind of a theme we've heard before with Robonaut 2, as you mentioned, we're hoping that we can get it working so that it can do some of the more mundane tasks that it's not really a good use of astronauts' time to do, and this sounds like the same idea.
Yeah, that's exactly right. I mean, there are certainly a lot of things to do in space, and I think the routine stuff is not something we should be having humans do. We have humans in space because we want to make use of their brains and the fact that there are some things that only humans can do. But, the very routine, the repetitive, the mundane things, robots should take over those chores. They should do all this kind of work so that humans don't have to.
Absolutely, yeah. I think a lot of people on ground would like that to happen in their homes as well.
Station Huntsville.
So I guess I know you're seeing a bit of a delay, but at the moment the satellite, the Sphere satellite, is kind of floating toward the ground and now up a little bit, and all that is being controlled remotely.
Yeah, that's being controlled. Actually, it looks like it's being controlled by Mark at Mission Control in Houston. The Sphere, it's a little hard to see in the video that you're seeing streaming because it's not quite high enough resolution, but right now on the right side there's a little boxy, shiny thing you see on the right side of the Sphere. That's actually the smartphone. This is like I said, it's an off-the-shelf. This is a Nexus S Android-powered smartphone. It was, I guess, jointly developed by Google and Samsung, and this one was off the shelf. I mean, we actually bought it at a store, and you can go out. Or at least you could have gone out. This phone is now a couple years old. I actually don't know if it's still sold commercially, but it literally is a consumer device.
Okay. So, and it's great that we're able to make use of those sort of everyday things and turn them into something that's useful on the space station.
Yeah, and I think in particular things like smartphones. When we first started looking at what it would take to turn Spheres from a satellite into a robot, we sat down, we looked at all of the requirements, and we said, well, we need to have computing and a display and cameras and maybe other sensors like gyros and accelerometers. And you add it all up, and what you come up with is, well, we need a smartphone for that. And rather than go out and try to build our own custom engineered small little computing device, let's go buy something off the shelf and just modify it for use in space. There have been billions of dollars of engineering time, and here's a good picture. You can actually see the smartphone attached to the Sphere now. Billions of dollars of engineering spent on creating these wonderfully high-performance, low-power, compact, rugged devices called smartphones. So, we want to take advantage of that and not try to reinvent the wheel.
And this is going to be the first test of that, right?
Yeah, these smartphones were actually the first smartphones to be certified for use in space. They're in the space station. They've been there since actually the last shuttle flight. They were carried up on STS-135.
Oh, okay.
Back in July 2011. Last year, actually just about a year ago, we did our first checkout with the phones to verify that they would work well in space, and we logged lots of information from the phone just attached to a Sphere. But today is really our first opportunity to use the phone to control the Sphere itself. So here, like I said, really now the combination of smartphone connected to Spheres makes this nice smartphone, Smart Spheres free flyer.
Where'd this idea come from?
Which idea?
The idea of using the smartphone on the satellite.
Well, honestly, so I distinctly recall a couple of years ago, we were sitting in a conference room here at Ames, NASA Ames, trying to figure out what was going to be required to put spheres or to transform spheres into a free-flying robot. And we were working on a whiteboard, writing up all the requirements. And like I said, okay, we want a processor, we want
It just made sense.
all these things here, and of course, sitting around the room, everybody's sitting there with their phones, checking their email, right? And somebody said, "Oh, we really need a small little device that you can does all this," and everybody's like, "Oh, let's use a phone."
Well, what about the idea to use spheres in this way to begin with, to try and take some of the work off the astronauts?
Well, ever since this project, the Human Exploration Telerobotics project started, that's been almost 3 years now. We've been really looking at this common theme of, how can we make astronauts' lives more productive? How can we really offload tasks that fundamentally is, unproductive, or things that they just, really should not be spending their time doing? And so we've been looking at a variety of different robots. I mentioned Robonaut 2 and the Smart Spheres, obviously. And it's clear to us that robots come in all kinds of different sizes and shapes, and they carry different sort of tools and instruments. Robonaut 2 is a really great robot that we've been using for manipulation. So it has arms and hands, can reach out, touch and grab things. But there are other situations where you might want to move quickly, or you want to just be in free space. And for that, we've been looking at the need for a free flyer. There have been some free flyer experiments. Many years ago, there was the AirCam Sprint flight experiment that NASA Johnson did outside in space, and because we've seen that inside of space station, the spheres have been a really wonderful test platform for many years now. It really just made sense to us to see, could we turn these into robots and use them to do useful work inside a space station.
Okay. Well, thanks, Terry. One last question before you go. How do you see this project going forward? What's the next step?
So the next step, I think, for us, with all of our systems, and Robonaut 2 and Smart Spheres are only a couple of them, is really, as we're doing these experiments, really learning, how they work, what things we need to improve. That's going to allow us to go to the next part, which is really actually making functional robots that can be used day in and day out on board space station or future space vehicles.